All right, this is Susan Poss again. We're still working in section 5.3, and this is the second video. We're going to now talk about degrees of polynomials, and again, this is on down the road in mathematics. This is going to be very important for you to be able to identify the degree of a polynomial. Right, so we're first looking here at a monomial, some multiplier k in front of the base x raised to the power n. And that n is where we're going to look in order to determine the degree. So the degree has to do with the exponent. So if we're looking at a monomial, let's do an example here. Let's say that this is a 5m to the third, then this monomial has a degree of 3 because the exponent there is 3. But sometimes monomials have more than one variable. And so what we have to do there is we sum up or add up the powers or the exponents. So on this example that we have here, let me put it out to the side, 4x squared y cubed, you can see there we have two variables. The degree on the first variable is 2, the degree on the second variable is 3. So we would say this thing has a degree of 5 because 2 plus 3 is 5. We'd call it a fifth degree monomial. If it's just a number by itself, a non-zero number, it has a degree of 0 because it has no variable. We look for variables and their exponents in order to determine degree. So if we have any kind of constant, its degree is 0. All right, so let me show you some things that are not monomials and tell you why. This is not a monomial because it's got two terms. This is actually what we would call a binomial. This next one is not a monomial because it has a variable in the denominator. Same reason over here. We can't have variables in denominator and fit the definition of a polynomial or monomial. Here are some examples of things that are monomials. And you notice this one doesn't have a variable in the denominator. It has a constant in the denominator, and that's okay. And the others all have whole numbers in these positions of the powers. So good examples of monomials. Another definition here, the degree of a polynomial is the highest degree of any term in the polynomial. And the coefficient is the number multiplier that sits on the largest degree term. That's called the lead coefficient. All right, so let's look at some examples here. A lot of words there. I know, I'll try to give you some examples. So here are some polynomials. The degree on the first term is 3. The degree on the second term is 3. This thing is called a binomial. And because these are both matching, we could actually combine those. We haven't talked about that, but we could add the 5 and the 7 and combine those to get 12x to the third. So this is an example of a binomial of degree 3. And the lead coefficient, I'm going to call this 12. All right, so let's look at this next one. This one is a trinomial. The degree on the first term is 2. The degree on the second term is also 2. And the degree on the third term is 1. So I would call this a trinomial. Of degree 2, because that's the highest degree that I see there. And actually I would probably, if we were actually working this, I would go ahead and combine those first two terms because they are like terms and tell you that the lead coefficient, that is the coefficient on the highest degree term, in this case, is 8. Okay, this last one, the first term is degree 1. Second term is degree 1. Third term is degree 2. And the last term is degree 0. Remember we said terms that were constants, no variable, would have a degree of 0. So this is an example of a polynomial because it's got 4 terms. Anything more than 3, whoops, can't talk and spell. Anything more than 3, we just put into that umbrella polynomial category. The highest degree I see in here is 2. And the lead coefficient, remember that is the number multiplier that sits on the highest degree term. So in this case, that's the negative 2/3. All right, so that's a good place to stop for that.